Hi, welcome back to Byte Forever. Recently, I've been coding an Alien Invader game in assembly language for the ZX Spectrum. I've been doing this, shall we say, the easy way on a PC, writing the code in the text editor, using the Pasmo assembler to build the code into machine code, along with a loader that will run on 48K ZX Spectrum. Now, this is great fun. You can check out the code and the game. I did both put this on GitHub, the source code, and itch.io, both free to download. See the links in the video description to that as well. So as I say, it's all great fun. Sometimes you want to go back to bare minimum of what's possible, kind of just like a palette cleanser. With the understanding that it's much harder to produce anything meaningful. Certainly anything like a full complex game would take. That'd be a big project. It's possible though. So to get to the point of this video, I'm going to run up an emulator and load a program called HexLD3. We can use this to write machine code, and you can run this natively on a real ZX Spectrum, provided you have a div-MMC or similar loading mechanism to load snapshot files. Again, there's a link in the description to this snapshot file. It's a .sna file. By the way, I typed this in from the excellent book called Mastering Machine Code on Your ZX Spectrum by Tony Baker. I think I mentioned this in a few other earlier videos of mine. This was published in 1983. And you can get the book on eBay. There's loads of copies around. That's what I did, because I like to have a hard copy of the book. Someone, I think, put it on archive.org as well. So we're going to start off with a really simple machine code program that quickly fills the screen with a colour, like say blue. And then we're going to modify that code to change the colour. This is dead simple stuff. It's as simple as it gets almost, to show something visually and also shows a bit of how fast machine code is. If at the end of this video isn't too long, I might try and make some changes, say to cycle through all the colours. I just want to do a shout out. I like to try and start doing this in videos, and today it's Animated Alex. Go visit his channel, again the link in the description. He's done loads of cool ZX Spectrum basic games, now also doing some machine code, and who knows, maybe this HexLD3 program might help him. Who knows. So we're on a ZX Spectrum emulator. This is what happens when you just load the snapshot file. You get this. I'm not sure what that printout is, but if you just run the code, it's a basic program, but there's loads of machine code. As I say, it is possible to type all this in yourself from the Mastering Machine Code book. I did that, and it did take quite a long time to get it right. You first, I think, have to start off by doing a HexLD program. That's a very simple program that all you do is enter code and you can run it from a specific address. There's a HexLD2 program which adds to that, and then this is the sort of full version. As you can see, it's a really basic menu. So there's different options there, like write in code, that's run 100, inserting code into different places, deleting code, replacing, copying. I tend to just go for, in the simplest case, run 100 first. So it prompts you to ask for an address. Now, a good place to put the code is 8000 in hex. And this, by the way, this program, all the numbers are accepted in hex, so that's quite cool. It saves on the typing a little bit. So we're going to start writing our code at 8000. That's a good place on ZX Spectrum to put your machine code. And what we're going to do is this, like I say, is programmed to fill screen memory. Now, I was hoping to put kind of like a little screenshot of the assembly code for this, but we're just going to dive in and start typing in the assembled version, which is in machine code, and then I'll explain each row as we go. So 21 0058. That's actually 21 in hex is the instruction LDHL. So that means load the HL register, and the next number 0058 is actually byte, high byte, low byte, which means that when you're reading it, it's actually 5800, and that's the start of attribute memory. Attribute memory is what sets the colours on ZX Spectrum. There's 767 bytes of this, or 768, sorry, which means you're just setting 8x8 characters to a particular colour. So there you go. When you press return, it puts the address and that code up there. So that's entered into memory now. So next one we're going to do is a 110158. So 11 is the LDDE instruction, which means loads the register DE, which is 16-bit register again, like HL is. Load it with the address that follows that opcode, and in this case, a high byte, low byte, it's going to be 5801. Obviously, because of the high byte, low byte, you're entering it again, 0158. It does take a little bit of time to adjust your brain to that, but it is possible. Next, we're going to do 01, which is LDBC, and it's going to be FF02. So what that is a load BC register with this is 16-bit register again on the Z80 CPU, and we're loading it this time with 02FF, high byte, low byte again. So 02FF, that is 767 in decimal, and that's the size of the attribute memory -1. So what we're doing is setting up all these things for the instruction, which is LDIR, which without going into too much detail, basically just transfers data from one memory location pointed to by the HL register to the memory pointed to by the DE register. We've set them up already. HL and DE are incremented, and the BC register is decremented. So if BC is 0, it stops, and so you can see what's happening here. We're just basically copying from an initial point, and that initial point is the HL register. We have to set the HL register to the value we want, and that's what we're going to do next. So that is 3608, and that is the load indirect HL, so load the memory location pointed to by the HL register with the value, the 8-bit value following that, which in this case is 08, and 08 happens to be the colour blue on the ZX Spectrum. Now we're going to do the all-important LDIR instruction, and that is the opcode EDB0. So you see it's a 16-bit opcode. And then finally C9, and that's just returns basic. So that just means once your code's run, goes back to basic, your machine doesn't lock up or anything, you can carry on. And there it's asking us it's prompting us for to enter memory at 800E, which is the next one. If you just press return, the code just drops out. So if we go run again on basic, we can actually list this code. If we do run 10 and then put the address 8000, there you go. So that's all the machine code. Obviously it's printing full screen. I think I modified this from the Tony Baker version, so it does 8 bytes wide and the address, which is quite good. I'm not sure, I can't remember. This is a long time since I think it's about 3 years since I typed this in. I'm just returning to it now. So there you go, there's all the machine codes in memory. Don't want to scroll, so just press N. And let's run it now. Let's run this code. So just do run 700, which is the option there. And it'll ask us for an address. So we put our machine code 8000. So fingers crossed we entered it all correctly. And when we press return, it should fill the screen with blue. There we go. So it did fill the screen with blue, but it also then exited with C9, and you can see the bottom 2 rows, they've kind of gone back to the background colour. That's just the way that it's like when you run a basic program, it just prints stuff in the bottom 2 rows. If you didn't drop out a machine code, it would have just stayed at the full blue screen. So I think, what should we try and do now? So we could try and change to a different colour. Maybe if you're playing along at home, you could do this yourself. So really what we want to do is list the code first so we can work out. So you see here, it was the LD brackets HL, so the indirect load of HL at 8009 with 08, which is blue. So if we now, press key. So I don't know what happened there. So we want 8009, and we want to overwrite that with a different colour. So basically it's best to just go run 100 now, but put in 8009, and let's so again we need 36 LDHL indirect, and let's try, what should we try? I'm not even sure what 7 is, but what colour that is. But so we can again list this code. So let's just run 10 to view it, just to check it went in, and there you go, 8009 3607. So that's correct. So if we now run 700 again, we can rerun the code, and hopefully we'll see what colour it is. I'm not even sure what it is. Oh, it's black. Okay, there you go. I was hoping for like some other colour. Let's change it again. So let's do run 100 right into 8009. You can see this program's quite good. It's fairly simple, but it does allow you to save time entering machine code. Again, once you start doing this, you'll memorise that 36 is LDHL, or LD indirect HL. Let's try 06 and press return again. Run 700 is to run it. 8000 again. Oh, that's black again. Oh, but the text, if you see the text is yellow. Yeah, I wonder why that is. Let's just. I think that's because we need text there for it to actually. Because the first time it did actually fill it all with blue. Let's try again. 100 to 8009, 36, and what we had was 08 originally. I wonder if it's just 8 onwards for the next 8 bytes of the... Oh, it could be the light and dark versions. So let's just run 700 to run the code. And again, we want 8000. Oh, there you go. So I think, yeah, I have to scratch my head and think why that actually is. That it's doing it black, but the run address came through as yellow, apart from when we did 08. Let's just do run 100. We're going through a bit of an iterative process here. So I want to load with, let's say 09. So that's like one after. I expect this screen to actually be filled with a colour now. Fingers crossed. Run 700. Enter the address again. 8000. Oh, it's blue again. Oh, the text is blue now as well. Ah, this is the byte. This must be like the encoding of it. Anyway, I'd have to do some Googling as to what happened there. Yeah, you get the idea. Please, if you're interested in this, see the links in the description and have some fun with an old computer, old hardware, or old emulators. Well, new emulators of old computers. And as always, thanks for watching, and bye for now.